All right, this is our first PowerPoint video over the new unit that we're covering, and our first PowerPoint is called The Mole. And as you can see here, we've got this beautiful drawing here of a mole. This mole obviously is more of an animal than what we're going to be using in chemistry, but I thought the sunglasses were nice. Thought we'd start out with that. So the objectives for this lesson that we're going to be talking about is, first of all, I want you by the end of it to make sure you understand the concept of the mole, what a mole is, how it's used in chemistry, some conversions that we're going to do as well. So our first objective is to understand the concept of the mole, and then our second objective is to make sure that we know how to convert between the moles of a substance and the particles of that same substance. So first of all, a mole, what is it? Actually, there's lots of different definitions for a mole. First of all, a mole can be a small cylindrical mammal that's adapted to a subterranean lifestyle. Pretty handsome, I must say, is too. I don't know if you guys see that or not, but pretty good looking animal there. Okay, mole can actually, if you pronounce it in Spanish, is actually mole, and that's a Mexican sauce made from chili peppers, spices, chocolate. Sometimes they throw some peanut butter in there. It's actually really good if you've never had it. A mole could also be a spy who's worked his or her way into an organization or country. And then for our purposes, this is the one that we really care about. A mole is just a unit that we use in chemistry when we're talking about the amount of a substance. So a lot of times when we're talking about the amount of something, we usually measure that in grams. But a lot of times we're going to use moles as well, and we're actually going to learn here in a couple days how you can convert between the moles of something and the grams of something. But it is something that we use in chemistry to help us figure out the amount of a substance used. Okay, so a mole. Here's our same definition from before. A mole is basically just a number. So a mole is actually equal to 6.022 times 10 to the 23rd whatever. So I want you to think about it like we use the word a dozen. We know that 1 dozen is equal to 12. 12 what? Well, it could be 12 roses. It could be 12 donuts. It could be 12 of anything. Okay, but what do we use instead is we use the word a dozen. And so with a mole, it's the same idea. Instead of saying 6.022 times 10 to the 23rd of whatever we've got, we can just say, oh, that's equal to 1 mole. Now this number, this 6.022 times 10 to the 23rd, is what we call Avogadro's number. And it's something that we're going to use quite a bit here in the next couple of months. And something that we need to be very familiar with. And so here is our conversion is this right here, that 1 mole is equal to 6.022 times 10 to the 23rd, whatever. Sometimes this lasts 2, sometimes I will not put it on there. Sometimes I just put 6.02 times 10 to the 23rd, but certainly either way should be fine. So just like 1 dozen oranges has 12 oranges in it, so does 1 mole of hydrogen atoms have 6.02 times 10 to the 23rd hydrogen atoms in it. So if you have a dozen oranges, you have 12 oranges. If you have a mole of atoms, you have that many atoms. And now why do we use a mole? Well, you just saw, a mole is a really, really big number. But if you think about it, think about how many atoms are in your body. Think about how many atoms are in a table. There's a lot of atoms. In just 18 grams of carbon, which is a little bit more than 1/10 of a pound, so not very much, there's 9.03 times 10 to the 23rd atoms of carbon in that amount of carbon. So a mole is just an easier way of expressing the amount of a substance without having to use such big numbers. It's kind of like scientific notation, how we take a really big number and we make it appear smaller, or we take a really small number and we make it appear bigger. With a mole, we're basically kind of doing a similar thing, where we're taking a great big number, a number that's so big that we can't even really understand it, and we're talking about, we're using it to convert it to a smaller, more manageable number. So again, the number is 6.022 times 10 to the 23rd. And I want you to think about that. What that number means, if we're going out to the 23rd place, it means we're moving this decimal place 23 places over. And I'm not going to write them all out there for you. But it would be a very, very large number. The number is actually, the way that you say it is you say it, this 602, you would say it as 602 sextrillion. And it's a number that is so big that really we can't quite comprehend it. Here's how I want you to think about it. I want you to think, if you took a piece of paper and then you stacked another piece of paper on top of it, you know how you get a piece of paper out of a package of paper. If you had 1 mole of pieces of paper, what you would have is you would have a stack of paper that would go all the way to the moon and then halfway back to Earth. That's how big this number is. If you had 1 mole of dimes, that 1 mole of dimes would cover the entire Earth with dimes, and then it would be 10 miles deep. So you would have dimes covering the whole Earth and going 10 miles up into the atmosphere. So it's a really, really big number. But if you think about it, atoms are really, really small. And so we have to use something to kind of convert between this huge number of atoms that we have and using smaller, more manageable numbers. So how do we use these moles? How do we do these conversions? So just like a dozen, moles are a convenient way to convert a big number of whatever into a more usable number. So here's a simple one. We know that our conversion here is that 1 dozen equals 12, and I'm going to just put ... That means whatever, 12 whatever of something. So if they want to know how many dozen are in 72 roses, we're going to start with the information that they give us, 72 roses, and then we need to cancel roses, and they want to know dozen. So what is our conversion from dozen to, in this case, roses? We know that 1 dozen equals 12 roses. And so our roses here will cancel out, and then our math is 72 multiplied by 1 and then divided by 12. So 72 times 1 is still just 72. So really our equation here is just 72 divided by 12 equals 6 dozen. Oh, well, that's super easy. Well, of course, we're starting with an easy one to help you get going here. Let's see. How would we do this one then? How many moles are in 9.35 times 10 to the 24th atoms of carbon? So this number, remember, think about how big a mole is. Now we're going even another decimal place farther to the 24th power. That's a really, really big number. So our conversion again, 1 mole equals 6.022 times 10 to the 23rd. Again, ... whatever that happens to be. So if we're starting with 9.35 times 10 to the 24th atoms, and this should be something that you should be writing down right now as well. And now I want to cancel my atoms, and so atoms have to go on the bottom, and on top we're going to have moles. Okay, they're wanting to know how many moles are there. And here's our conversion right here. So in this case, our ... our whatevers are going to be atoms. So we're going to say 1 mole on top, not 11, sorry about that. 1 mole on top, and on the bottom, I don't really have enough room here, 6.02 times 10 to the 23rd atoms. So now our atoms over atoms are going to cancel. So all we have left is moles. So when we do the math on this step, we're going to go 9.35, and then remember, hit the second EE or the EXP button, 24, divided by 6.02, and I forgot, again, I told you that I was going to do this. I forgot the other 2 in there, and that's okay. I'm just going to use 6.02, and then again, exponent, 23, and I get a final answer equal to, I've got 3 significant figures here, so my final answer is going to be 15.5 moles of carbon. And that's all you have to do to be able to convert between the moles of a substance and the atoms or whatever it happens to be, you simply use that conversion of a mole and get your answer. Okay, here's another one. So in the previous one, you'll notice that we talked about atoms of carbon. It doesn't have to be atoms. It can be, remember, whatever. So if we have 2.34 moles of CH4, they want to know how many molecules of CH4 we're going to have. So again, our conversion, 1 mole equals 6.02 times 10 to the 23rd. And in this case, they're asking us about molecules. So it's going to be molecules. Just like if it was oranges or roses, you could switch between those two depending on the question. So if we have 2.34 moles, and in this case we have moles on the top, so we want to cancel moles, so that's going to go on the bottom. And on top they're asking us about molecules. So, and we can't abbreviate molecules because then it'll look like moles. So we have to write out molecules. So we're going to have our conversion, 1 mole on the bottom, and then on top our 6.02 times 10 to the 23rd molecules. Now again, we've got moles on top, moles on the bottom, those cancel. So now again, our math is we're going to take 2.34 and we're going to multiply it by 6.02 times 10 to the 23rd. And again, as we do that, we're going to put it in the calculator the right way. So we're going to go 2.34 times 6.02 exponent 23. And again, with 3 significant figures, I get a final answer rounded correctly to 1.41 times 10 to the 24th molecules. And that's it for that one. All right, so let's go back to our objectives here real quickly to the beginning of our slide. Our objectives today were to understand the concept of the mole. So hopefully you understand that the mole is something that we use in chemistry. It's really just a conversion like we use with dozens or a pair of something. It's a way to convert between a very large number to a smaller number, and etc. And then we did a couple of examples of converting between the moles of a substance and the particles of a substance. So now your job is to go back to your module and complete the assignment over the mole and then move on.